Thanks for joining the TypeScript for F# Zealots talk. So this is a talk I'm doing that's not primarily about F#, which might be a surprise to some people watching this. As many people who have seen some talks from me know, I'm an F# person. But I thought I'll speak about somewhat different experience that I had recently. So I couldn't find better illustration for zealots than this meditating kitten who definitely knows what's the best programming language to use. I thought everybody needs a meditating kitten in these days. So this is going to be a fairly opinionated talk, and I'm hoping that people will disagree with some of the points, and we can sort of follow up in the comments. I'll be on Slack as well if people have more things to say. So why should you listen to this talk? I'm going to be talking about my experience with using TypeScript for one project that I've been working on, and I'll say a little bit about the project first, just so that you know what kind of things I've been doing, what sort of motivated the talk. And then I'll say a few things about TypeScript, and I'll cover both the things that I thought were nice about it, coming from an F# perspective, and the things that I thought were not so nice coming from an F# perspective. Now, I don't really expect everybody to be an F# zealot, so the title of the talk was a bit misleading. I'll show you some relevant bits of F# code, but it's going to be fairly introductory. So the thing I've been working on, and this is a sort of project that we've been doing using, or bits have been using TypeScript, is this system that I've been building in collaboration with some people in the Alan Turing Institute in London, which is trying to produce a new notebook system for doing data science. And it does a few interesting things, which I'll talk about. And the important bit is that there's a client side that's fairly non-trivial or does some interesting things, and that has been implemented in TypeScript. So what does this actually do? There's a few things that make this project interesting. First of all, if you're doing data science, then these days, typically your entire sort of workflow has to be in one language, typically Python or R. We're doing something where it's easy to mix multiple languages in a single project. We're also doing quite a lot of clever work to track dependencies between different bits of code in your notebook, so that when you change something at the beginning, the things that are later on get invalidated. We want to be able to do more in the browser. So if you just sort of doing some interactive data exploration, that is something you should be able to do straight in your web browser. And we have this feature called AI assistants, which are clever tools that help you with some of the common boring data wrangling problems. So you can actually try this yourself if you go to WRATTLER.org. We've got a button which will load an instance of the system on someone else's computer in the cloud. So you can sort of experiment with it quite easily. And what you get is this. I'm going to make this a bit bigger, just so that it's easier to see. So you get the way the system works is that it integrates with the standard environment that data scientists use called Jupyter. So this is not really a sort of standalone system altogether. It integrates with what people are already using, and it adds a new kind of notebook. So this whole thing that I'm scrolling through right now, this is actually running the bit of code that we wrote. So it's hosting sort of standalone notebook inside this bigger IDE, and I can do various things. So here's a sample in Python. where I'm just creating some sample plot. I'm not really a data scientist, so I'm not going to tell you much about data science. I'm just going to tell you about building tools for data science. Now, the more interesting thing is here. So what I'm doing here is I've got a cell or code block written in Python. And what this does is that it uses this pandas library to read a CSV file from GitHub. And it reads some finance charts. And then I can evaluate that. But following that, I've got a JavaScript code block that loads the Plotly data visualization library. And I've got a JavaScript code block that accesses this AAPL dataset that I loaded in the previous Python code block. So the really interesting thing here is I can mix Python and JavaScript, and if I run this without any sort of explicit passing of data between Python and JavaScript, I'm able to build nice interactive charts. So this is showing some finance data. My zooming skills are quite bad. So that's one thing we're doing. The other interesting thing is how does the tracking between dependencies work? So in a typical data science system, what you get is you just have to run through the code sort of from top to bottom. And if you miss something at the beginning, later on you'll get errors saying you didn't run, or a variable 1 is undefined. So this system does something more clever, where here I'm defining data sets 1, 2, and 3 in JavaScript, Python, and in R. And then I have a bit of code, again, JavaScript, Python, and R, that just connects all these 3 data frames together. And if I try to run one of those, then it figures out that it has to evaluate all these cells that I had at the beginning. So it does that. Those create some data frames. And then it evaluates the one I clicked on. But it doesn't evaluate another sort of cell that I had earlier in the notebook that doesn't really, where the current one doesn't depend on it. So it does a bit of clever sort of tracking to figure out what depends on what. And I can even visualize this. So we have this little visualizer where you can see how the different bits of code all depend on each other. So there's some cells, those are the bluish markdown cells, which are just code, just comments. They don't depend on anything. But then there's some R code, some Python code, and some JavaScript code, and you can see that this depends on the inputs, and outputs depend on that. So this is what we've been building, and I just wanted to give you a clear sort of quick demo of the system itself, so that you know what's my sort of background, where I'm coming from. So the client side, what I was sort of playing with in the browser, that's all implemented in TypeScript. And as I admitted already, I'm an F# person. So why did we end up with TypeScript? So this was a project with a larger team where more people in the team knew TypeScript, and that was one of the motivations. And I wasn't really working on this full time, so it was quite important so that sort of work in a way where others can be in control and do things even when I disappear for a few weeks. So that was one of the reasons for choosing TypeScript. The other thing we thought was that the Jupyter platform itself is implemented in TypeScript. So if we do the same thing, then maybe people might contribute a bit more, which is a nice idea in theory. In practice, that actually doesn't happen. So getting outside contributors is always difficult. So what are the sort of reflections on TypeScript based on that project? And this is sort of reflections coming from an F# perspective. So maybe it's sort of interesting and not necessarily a mainstream view on TypeScript. So that's why I thought this was an interesting thing to say. The good thing is that you can actually do fairly nice functional programming in TypeScript, or you can use the sort of elegant, beautiful functional architecture, and I'll spend quite a bit of time showing how that worked. The bad is that the TypeScript system does make some difficult trade-offs in the type system. And this is inevitable because that's how TypeScript was designed. It's sort of designed to deal with full JavaScript world. So you have to make those changes or make those decisions. There's nothing else that could be done, but it does make certain functional programming patterns quite annoying. And one thing that I found, which I called the ugly here, is you would think that TypeScript has the sort of simple JavaScript syntax, but that isn't really the case anymore. So I'll have a few complaints about syntax. It's not quite the what talk, but you'll see what happens. So I want to start with the good things, so that those of you who are interested and like TypeScript can watch the first part of the talk and then switch to some other session if you don't want to hear me rambling about the bad and the ugly. The good thing, so the way we structured our system is we're using this ELM style architecture, and we've actually implemented quite a lot of that ourselves, except for one key bit. And the reason, the nice thing in this architecture is if you're using functional style, you really just have two immutable types representing the state, the model, and event, what is happening in your notebook. And then you have two functions, update and render, and they're purely functional. And our implementation has very few dependencies. The nice thing about this model is that it's really easy to debug and understand what's going on. And in a system that's fairly interactive, where sort of cells are evaluated in the background and stuff like that, this has been quite valuable. So why not just use React? And this is a question that I think is important, because I'm going to show you how to implement a few things from scratch. And I think this is very often a sort of good approach if certain things are true. So our user interface in the system is not very fancy. Like it's really just this page. So the fancy things here are, well, there's a few buttons for like moving things around. We're using the Monaco editor. That's the only sort of rich component that we need. But we're not building like complicated forms for entering dates and stuff, where React has a lot of components. So we don't really need a lot of components. The other thing is that this is a project that's been going on for a few years, and it's sort of done at an academic pace, where you get back to it sort of every once in a while when you add new things. So it's not exactly great if all your dependencies completely change between every time you sort of get back to your system. I think this is something that's fine if you're sort of constantly working on a project every day or every week. But if you have longer gaps, then I think having fewer dependencies is actually what makes the development more sustainable. And we do like the fact that we have more control over how things work, because, for example, here you need to integrate with the Jupyter environment, all the stuff around. So you do need a certain level of control of how the user interface is rendered. And it turns out that the core logic that React or all these sort of modern programming methods for the web, what they do is actually pretty simple. So I'm going to show you the way the architecture works, and for this part, I want to show you the F# code first, and then how the same thing looks in TypeScript. So this has really two purposes. One is, I think the F# version of it is quite clean, and it conveys the idea very well. So I'll show you how to do this in F# to explain how things work. And if you're familiar with or you can use the F# part to make sense of it, and then sort of see how the same thing works in TypeScript. And I think that the other thing is that the sort of TypeScript version will then help you understand what's going on in F# here. So I'm just going to start my sample project. And I've got all my code here already. So let's just wait until the Webpack server launches. So here in F#, I'm using Fable, which is F# to JavaScript compiler that takes my F# code, produces JavaScript, and passes it through the all standard JavaScript things like Webpack for building and live reloads. And this is running 7071. So right now I've got a page that says welcome to counter. This is not going to be a super inspiring demo. I'll just create a little counter where I'm going to count the number of clicks on a button. So the way to do this is I have two types that represent model and event. And model is my state in the application. So in my state, I'll just have count, and initially let's start with 0, and then when I'm rendering it, then I'm going to put I can say current count, and then add the current count, and the current count is something that comes from I need some more parentheses, from this state variable. So the way the system works is that I define what's my state. I define an initial state. So my state has count. It's an int. Initially, it's 0. And then I define a rendering function that uses this little domain-specific language for generating HTML, and it can access the state. If I save this, then I get current count is 0. And I can add some buttons to increment and decrement. So I'm going to create a button, and this is going to be text +1, and I'll add a button for -1 as well. If I save this, I now get my buttons. And how do you handle events in this architecture? So the idea is that you define a type for events. And here I'll just define one message which says update the state, and it's going to take an integer as an argument, and that's going to be +1 or -1. And in the user interface, you can then trigger those events. So I can say whenever click happens on the +1 button, I want to trigger the update event with +1. And whenever click happens on the -1 button, I'm going to get -1. And the key thing is I now have to implement this other function called called update, which takes the current state and the message, and we're going to pattern match on the message. If this is update by some number, then we're going to return a new state where the count is the original count plus the difference. So I think this should actually do all I wanted. Let's see if it can count. Can it count? Plus works, minus works. All right. So this is the core thing. Now I want to make one more change. I want to do it so that the count initially is not started. Like you start with a counter that's not initialized, you have to click the start button. And the F# way of doing this is to use the option type. So now I'm saying a count can be a number or it can be not set. And initially this is going to be none, indicating this has not been set yet. And in my rendering, and I'm going to save a bit of typing here. In my rendering, I'm going to pattern match on the count. And if this has not been set, meaning I haven't started counting yet, I'll generate a page with welcome to counter and a start button. If the current count has already been the counting has started, I'll generate a page with. And the start button is going to send a new type of message, which I'm calling reset. And one nice thing in F# is that all those things are checked. So I get a message here saying, in my update function, I'm not handling the reset message. So if I get the reset message, then this is the case where I want to return 0 to initialize my counter. And I'm also going to have to pattern match on the current count. So reset, that ignores the current count. But if I'm ignoring, if I'm updating, then I need to get the count and update it by a certain number. And this is going to be set, which is indicated by the sum case. If I get update, but I haven't really started counting yet, this is an invalid operation. I'm just going to ignore it, although you should probably throw an error message in this case. So if I save it, I have a counter where I can start and then I can count. So this is all I wanted to show in F#. I'm going to shut this down. And I think this is really a nice approach to implementing reactive web applications where you're in sort of, it's not, I wouldn't necessarily use this if I was using something with like lots of forms where there's standard components for doing that. It works really nicely for this case because we're basically creating our own user interface. And F# has this really nice way of modeling domain logic. So this is another example where I'm saying I'm implementing a to-do list. The model is the list of to-do items. A to-do item has a title and a due date. And what can happen is I can add a new item or I can reset. And in the ELM architecture, you have these two operations, update and render, where update takes the current model and a message, what's happened, and it produces the new state, the new model. Render takes mainly the model and produces an HTML output. And it also has this trigger operation, which is this first function here. And that's used for triggering events. So can we do the same thing in TypeScript? There's a few things that I'm going to be using. So first of all, I really like the way F# type checks everything. And if you're using TypeScript, then TypeScript has various flags that you can turn on for enabling various security checks or checks in the type system. So there's strict null checks flag to avoid nulls, and no implicit any to avoid this any type, which means any JavaScript value. So this is really useful, and we've been using that. And there's a flag just strict which turns all these things on. So I'll show you how this works. And it turns out that you can use TypeScript actually reasonably well for implementing both the record types that I was using in F# and these discriminated unions that I was using for representing the messages. Now, those aren't really immutable. So here you just rely on being disciplined about how to use them. And it's one thing that we didn't always do well in our project. So we did occasionally mutate something by accident and then ended up scratching our heads for half an hour to find where we did that. So what I want to do now is do basically exactly the same thing, but in TypeScript. So I've got the same stub implemented here, and I'll start it. And in this project, and I'll send link to the code, the only thing that I'm not really showing you is this elmish.ts file, which is using the maquette library. And what the library does for us is the updating of the web page, updating of the DOM. So this is the sort of standard virtual DOM trick where we're not really replacing the whole content of the screen. We're just updating bits there. But you could see that this was all my code here is some, 15 lines of code. So I'm not really hiding anything complicated, and I'm just using one external library. And I'll do exactly the same thing as I did before in F#. So I'll have a type representing my state called model, and I'll have a type representing my events. And then I'll have a render function which says, welcome to counter, and an update function where I do the update when some event happens. And I have an initial state, and then I just call my helper to start the app. So this I've got running on another port. There it is, just to show that this is actually running. If I say from TypeScript, this should sooner or later reload. There it is. It's reloaded. Says welcome from TypeScript. So I want to recreate the same thing I did in F#. So the model, this is going to be quite easy. I'll just have count, and that's going to be a number. And the more interesting thing is, how do you actually represent those events? So I had two events. I had reset event, and the representation you can use in TypeScript relies on two things. It relies on union types, where you can say a type is one type or another type. But it also relies on this very interesting trick with singleton types, or where I can say a reset event has a kind, and the type I'm using here is not string. It's just a constant string called reset. And a reset event just doesn't have anything else. I also had update event, and this is going to have a kind update and a number by how much. And then the event is either reset event or update event. So this is really pretty much the same as the F# discriminated union, and we'll see that this is quite interesting when we use this. The way I'm going to do the rendering, well, first of all, I should do my initialization correctly. So let's start with count equals 1, colon 1. You can see the biggest problem for an F# person coming to TypeScript is you have to use colons and not equals. And this bit here is the same kind of HTML rendering. So we're going to render an H1 with the current count. Current count is followed by, we get the count and convert that to string. So that should be a good start. And now I need a button. I'm going to spare you some of my slow typing attempts, and copy those 2 bits from here. So I've got 2 buttons. and one is the increment button, the other is the decrement button, and they do have on-click event handler, where if I click on the button, it will trigger the event. Now, the interesting thing here is when I'm triggering the event, this is really determining that I'm triggering the update event. So this is producing a value of the update event type. And the interesting thing I need to do here is do the updating. So if I get, well, let me first see if it actually runs. So if I save this, I do get current count is 1, so that works. And my buttons don't do anything yet. So how do I get my buttons to work? Let's see. And this is the bit. This is the really interesting bit. So if you do evt dot, then you can see that the event, which is my event, has this property called kind, and kind is of type which says this can be 2 strings. It can be either the reset string or it can be the update string. Now, in some cases, if this is update, there should also be a property called by, because then we're specifying whether it's +1 or -1. How do we access that? Well, this is the bit where TypeScript is doing something quite interesting, because if I say switch over the event kind, I don't need that. If the case is, and I'll and actually, the editor even knows this. The editor knows that evt.kind can only be 2 things. It can only be reset or update. So if it's reset, then we're going to return a new state where the count is 0. If this is update, then, and this is where things get interesting, because if I do evt dot, I do actually get by in my autocomplete. So how does this work? TypeScript knows that event can be either reset event or update event. And it knows that this is determined by the value of the kind. Now, if the kind is reset, there's nothing else. But if the kind is update, there's this by property here, which I can now access to increment my count. So count is going to be the original count plus by. So with a bit of luck, this should now make my incrementing and decrementing work. Seems all right. And the one last thing that I haven't implemented yet is this start button. So I do have a improved version of my rendering function here, which does the same thing that I was doing in F# before. So if state.count is not null, then I'm counting, and I'll render the current count and do the plus and -1 button. Otherwise, I'll just say welcome to the counter, and we will start with count being null. Now, if I save this, then I have the start button, and now I can do counting. Now, one thing I haven't done here really is I haven't dealt with these nulls very nicely. So I just set count to null, but count is actually a number. And if I wasn't careful, I could get various errors caused by null. So this is the default sort of bad behavior you get in old school JavaScript. But the nice thing in TypeScript is that I can enable these strict null checks. So if I, in my config, say strict null checks on, then suddenly I get a bunch of errors here. Where do I get a bunch of errors? I get an error here. So this is not the most useful place for getting my error message. the main issue is that this actually does a sort of, well, TypeScript doesn't infer that this is model because it's not model. It couldn't be model because model doesn't allow null. So I have to change my types a little bit, and I quite like the way that the TypeScript handles nulls, because you can say a count is of type number or null. So you're explicitly saying you can get null here. And well, if you do that, then suddenly in my update, I can't just access count and do calculations with it because it can be null. So I have to do the same thing which I did in FSARP. In FSARP, I use pattern matching on option values. Here I have to say if state.count is not null, then I can do this. Otherwise, I can just return state. And that's all I have to do to fix it. And this is sort of pointing out a potential issue in my code. And you have to be explicit about your nulls. So I do like this strict option. And it's pretty much the same as what I did before with FSARP and option types. So option types are sort of a way of doing the same thing without having all this extra machinery in the language. Now I can be even more strict and turn on strict type checking. And what this does, it gives me an error here. So one thing this enabled is that I now have to explicitly, well, I'm not allowed to have variables which will implicitly have a type any. So in TypeScript, the any type is a very useful thing for interoperating with JavaScript, because if you don't know what object you may get from JavaScript, you just say it's any, and you can do anything you want with it. In TypeScript, you can turn this off, and now I have to be explicit about my types. The sad thing is that TypeScript doesn't really infer all the types. So here I have to do it manually, and I have to say that trigger is a function which takes an event. I guess I have to say takes an event and produces void, but you have to say, you have to call it somehow EVT. So adding all those type annotations is something I don't find very pleasant. So that was the counter demo. And the main point here is really, I think this is a very nice architecture, and it works quite well with TypeScript. Here I'm just sort of implementing things from scratch, because that what suits our project for two reasons. The user interface, we're building most of it ourselves. So it's a very custom UI. That's one thing. Second, this is something that's not going to be sort of updated every single day. So we don't want to rely on the sort of breaking changes by others. So in TypeScript, you can model what FSARP knows as discriminated unions using these interfaces with singleton types and the union constructor. And you can put this nicely with the ELM architecture operations. And the type signatures of those, I think, are somewhat painful to read, but it's the same thing as in FSARP. So you have update takes the state, an event, and produces a new state. Trigger, a render takes this trigger operation for notifying the system that something has happened, state, and produces an HTML node. So what are the interesting reflections? I'll demonstrate this using a few examples. So the first example, and coming from our Wrattler project, is that Wrattler is extensible and you can add new kinds of cells. So we had Python, JavaScript, Markdown, but you can build your own cell with your own user interface as well. And to do that, you have to implement some interface. So this defines what is a language plugin. A language plugin defines the language, that's just a string, has some editor, which is another object. And then it defines how you parse code, how you evaluate code, how you save code, and how you bind, which is our name for a sort of step that happens before evaluation where we construct dependencies. So all those things you have to implement. And in our actual system, I've got one example where we're implementing a little language plugin called merger, and this is just a demo. It's not useful for anything practical. Where the idea is you have a little language that all it can do is it can merge data frames. So if I turn this on and save my files, I've got another instance of Wrattler running here as a standalone thing. So this now reloads, and I turned it on, and I now have a new cell type, so I can add a merger cell, and this is using a little programming language, not even programming language, where you just say output data frame name and comma separated list of input data frames. So this is a domain specific language for merging data frames. It's just a demo, and if I evaluate this, what happens is it now merged 2 of my data frames. If I add a third one, then it merged 3 of my data frames. There's a bunch of code running here. And the relevant bits is I need to implement this interface. And in my implementation, I decided to just create a value using the object notation. So this is something I find quite nice. You can sort of define interface and implement that by constructing an object that has all the required things. If I remove one of the things that is required, then I get an error message saying you don't have that. So I'm implementing that object here, and as part of the work, and this is where the sort of interesting logic comes in. The way Wrattler works is that all those data frames that I've been merging, they're stored in a component called data store, and Python or R will put the data into data store, and when some other component wants to access that, they will have to fetch it from the data store. And then the result we put back to the data store. So here we have some code that calculates the current value and puts that into the data store. And this is a place where you just inevitably have any values because you're working with things that you get from the web. Now, the other interesting thing is that this actually, well, I'm not showing the getting of the data because that's in a separate file, but I'll get back to that. So I think there's few interesting things that I find quite tricky in TypeScript. One is this sort of, you can often do object-oriented programming with classes and interfaces. And if you're doing more object-oriented style with sort of inheritance, then you do want to use classes. Another thing that you get with classes is you can actually check whether a value is an instance of a class using this instance of operator. And this does not work with just an interface. It only works with classes. And if you want to have runtime checks, then you do need that. But the sort of object implementations of interfaces, which is what I've been using, give you somewhat lighter syntax. They're somewhat easier to use, but they don't give you this sort of ability to do the checks. So one thing that we've struggled with occasionally in our case was we just started with an anonymous interface implementation using the object, like what I'm showing here, and then for one reason or another, we decided we need to turn this into a class. And it turns out that you can do that. But the annoying thing, and I'm switching between the two versions, is that pretty much every single bit of syntax changes. So here you do colon, now this becomes implements. Here I say equal curly bracket, now I just say curly bracket. In the code, previously I had colons everywhere, now I just have equals everywhere. My function previously was defined as a attribute, which is implemented using the arrow notation followed by curly brackets. Now it's without that, just as a function, and the body stays the same. So this is one case where I thought there's some pretty crazy inconsistencies between the two different ways of doing the same thing. Now it makes sense because that's how JavaScript works, but I think this is one of the examples where the JavaScript heritage of TypeScript really means that doing certain things is quite painful. The way you do constructors in classes in TypeScript is the sort of standard way. You define a constructor, and in that you initialize all the fields. And to someone coming from an F# background, where F# has these beautiful implicit constructors, where you just, as you're defining the type, you take all your arguments and then you define all your fields. Switching to the TypeScript world, where you need to have explicit constructors, is just that's been made. It's a tiny thing, but if you're writing a lot of classes, you'll end up wasting a lot of time. Now, there's a few places where I managed to break the type system, or where the type system sort of does things according to the necessities of the JavaScript environment, which aren't very pleasant. So one of those is when you're using fetching some data from HTTP, always get response, or the data, which is of type any, and then if you're not careful, you can very, very easily get into trouble by sort of propagating that any value somewhere else in your code and causing all sorts of troubles. And you can remove some of those places where this error can happen by using the strict mode. And if you're doing the same thing in F#, there's I think F# type providers are one of the nice features that can help you with that, when you can sort of strongly type your responses. But if you're using Fable with F#, this is a place where you will easily notice that this is a problematic place. So you have to define some type explicitly, or you just won't be able to access it that easily. So that's where sort of F# makes things harder for you, but I think it's actually a price worth paying because it just removes quite a few errors. And I do have one very curious example. So this is a place where the fact that TypeScript is still just a JavaScript runtime underneath does cause a few surprising issues. So this is a bit of code that is actually pretty much based on what we had. We have this interface representing a variable. A variable has a name, and we have an object which we're using as a lookup table. You can sort of use the square brackets to index into it, and it's basically just a map or lookup table where, given a variable name, you'll get the variable. And I have a little function which returns the length of the name of a variable. So it takes the scope, which is our variables or data frames in scope, the name of the variable, and it says, if this variable is not undefined, then return the length of the name, otherwise return -1. And this is even in the strict mode, so this can't be null. And the question is, can this ever fail because the name is undefined? So in my type, name is a string. It can't be undefined, otherwise you'd have to say name on string or undefined. But it turns out, because this is underneath JavaScript, if you just call this and use empty lookup table and toString as the name of the variable, then this breaks and your code crashes, because this lookup is just the object lookup of JavaScript. And all objects in JavaScript have toString. That's the method that you can use for converting those to string. So this is not undefined, but it's not actually, as our type requires, a variable. So it's a function, it's not a variable. And this is, I think, a case where the fact that we're building on JavaScript, TypeScript can remove some of those quirks, but not all. And this was a case where we really, this sounds pretty arbitrary, but we really did spend an hour debugging this issue because we did have a variable called toString. The last bit I wanted to talk about is some of the things that I didn't find particularly elegant in TypeScript, but that were not really a major issue. So this is mostly about the syntax. And TypeScript inherits the JavaScript syntax, which is really sort of designed for not necessarily functional style of programming. So this is perfectly expected. That's a price you have to pay when you want to use TypeScript in a functional way. And this is again based on an experience of writing a piece of the Wrattler system, where one of the really sort of nice, interesting, innovative pieces of data science tooling we've got are these AI assistants, which are tools for semi-automated data wrangling. And I'll show you what this is. So I'm going to open another demo, and you can go to WRATTLER.org and play with this later on your own. So I've got one example here where I'm downloading some data on air traffic accidents, which is actually originally coming from Eurostat. And the way the data is structured is that you have a row representing accidents related to all airplanes that were registered in a particular country where the accident happened in a particular country. So for example, here, this would be a row that represents accidents that happened to aircrafts registered in Austria that happened in Cyprus. And it's very sparse. One of the issues with the data, though, is that they also include aggregates. So there's some rows that represent the total for the whole EU, and using that is quite tricky. And what I can do is I can say I want to use an AI assistant for outlier detection on my data set, and this will create a cell with custom user interface where I can just run the AI assistant and then ask it, how do you recommend I fix this code? And the assistant says, you should add a filter where CRegis is not EU28 and also geo is not EU28. So it looks at my data and finds the outliers, and it recommends that I add certain filters, and I can see what rows it actually removed. So this is a tool where if you're cleaning data, it can help you with some of the typical boring tasks. And in the implementation of this, there's a few things that I found quite annoying. One is that sometimes you have two ways of defining a function. You can do this using the sort of lambda syntax, which works in certain contexts, like when you're passing the function as an argument. So Here I'm defining a function that takes a list of AI assistants and generates an editor where the editor has certain initialization code. Now, this is written using lambda function, but if I need to change it to an explicit function, then again, I go through this process of making so many tiny tweaks in the syntax. So here, in the function notation, you just say curly bracket return, and then you return something. In the other notation, you have to say arrow, and then you don't need return. But if this starts with curly brackets, then you need extra parentheses around, because otherwise the parser will treat it as a code block. Another thing that I find quite tedious is in the code that constructs these HTML blocks using the H notation. In TypeScript, I end up with a lot of helper definitions, and then I end up with sort of one messy condition that says, depending on the state, do this or this or this. And in F#, this is one thing that can be handled quite nicely with list comprehensions, where I just define a list and then I say yield this user interface element or this element or this element. So you can embed quite a lot of logic in this code that constructs lists. So to wrap up, so I talked about about TypeScript from the perspective of an F# person, and also from the perspective of a very specific project, where our project sort of is long running, not very sort of ongoing all the time. It's re-implementing a plain user interface from scratch. And TypeScript worked quite nicely with this ELM architecture. And I did like the fact that we sort of implemented that ourselves, had a nice control over that. TypeScript isn't really designed for functional style, so some of the things will end up being ugly. And in some places, it's trying to be JavaScript. In some places, it's not. And this often leads to random surprises, like this toString thing. Would I sort of, when would I prefer F#? When would I prefer TypeScript? So I'm obviously biased here. As an F# person, I always choose F#, but I was working in a team where this was a team decision, and we did go for TypeScript. How do the two compare? So if you're using F# for the web with Fable, then I think the remarkable thing is that F# has this functional core, which is safe and clean and works. And the way Fable compiles this is that it avoids most of the all the sort of messiness of JavaScript. So you have the core language, which works nicely, is predictable, is understandable. And then there's the extra integration code, which inevitably has to make trade-offs. TypeScript supports many different styles, including sort of object-oriented and functional, and it doesn't really hide JavaScript. It's sort of JavaScript is one of the styles that TypeScript supports. And unlike in F#, where the core and the integration is quite clearly separated, I felt like in TypeScript this is not so much the case. So you always end up mixing different bits, and you can do it well, or you can do it not well. And it's really hard to sort of figure out what is well, what is not. So to go back to my meditating kitten zealot, who knows that F# is the right choice for everything all the time, I think the important things here from the talk were I was actually quite sort of pleased with using TypeScript in the way we used it, using the sort of plain Elmish architecture. You have to be very disciplined, and you're not really. You'll end up using TypeScript in a way that's not obvious. So I sort of thought if we go for TypeScript, people won't have to learn too much. That's not really the case. If you want to do functional programming in TypeScript, you have to learn functional programming in TypeScript. Just like if you want to do F#, you have to learn F#. So that learning is still there. TypeScript in a functional way is really different language than TypeScript in a JavaScript way. And a lot of these decisions really depend on the project context, so you always have to use your judgment. That's all I wanted to say, and I'll have a look at the questions now. So thanks for tuning in and for sticking to the end. All right, question. Is there a reason you're using interface as opposed to type? Seems to me that the interface is just a reference to, I have to move my window here, to Microsoft's inclination to OOP. Yeah, I think that this bit is something I found sort of confusing as well. Like there's so many different ways of doing things that I just ended up using interface because I think that's the first thing I was able to get to work. And I don't really have a good answer to that. It's true that this might be the case where TypeScript just sort of inherits a lot of different styles, and some of them are more OO. Like if you use OO, you might end up with classes and interfaces. If you're using different style, you'll end up more with types. So there's no good reason for this. It's just a random decision based on what I was able to get to work easily for what I wanted. But yeah, if you look at some of my type definitions, sort of earlier on, there's cases where you need to say type. There's cases where it doesn't really matter. Like here, this has to be a type because I'm defining a type alias. But the way you define the record types, I don't really know if there's sort of subtle differences. All right, any more questions? I don't think there's any other question here. So I don't think anyone's joining live on Zoom. So if that's it, then thanks again for joining. And I'll post all the code, including, most importantly, the two F# and TypeScript comparisons sort of side by side of the ELM architecture, which I think is a fun thing that people can play with later. Thank you.